Before you get started, could you just give a reminder of attendance? Have them scan the QR codes at the table.
So, well, this is a UNIX tips and trips workshop of just generally to get you started with the high performance computers and just some general quality of life things that I think will greatly speed up not only your research, but also sort of your future work. These are the kind of things you're probably not going to learn in class, but are going to kind of be the things that'll maybe make you stand out when you're first starting out at the lab. Okay. Yeah, so first, just a basic idea. So there's two types of interfaces. We have a GUI or a GUI. I pronounce it GUI. A lot of really older guys, if you have any professor or mentor that's been, programming bioinformatics since the 90s, they'll call it a GUI. I just call it a GUI. And then a command line. So this is a command line right here. There's no visuals whatsoever. There's only ASCII text. You can make little pictures with ASCII text, but it's mostly commands, whereas you also have a GUI, and this is what you think of when you think of a computer. It's all the physical buttons you click on. It's the folders you click through. Normally, this is what you'd see on your Windows. This is what you'd see on the HPC. But if you have a Mac or a Linux computer, you have access to both of these. And even on Windows, there actually is a more limited version of command line, which you'll get into a little bit later. The most important thing I think you should do is make an IUI HPC account. So you go to this link here, and it'll show you create more accounts. I've already created all of my accounts, so you won't see those, but you'll see little radio buttons that'll say Quartz and Big Red. I would just make for both of them. They're free for all students. You do need a Slurm allocation. We'll talk about that later, but in general, you should just have both of them. It's free. It's not going to hurt you. It'll make it so if you do use these eventually, or your professor is like, hey, let's move this over to Big Red and get you a Big Red allocation, you already have that set up. And it usually takes about 24 hours to get it done. So just having it done in advance is a good way to get a head start. Then an SSH connection. So this is how you will go and connect to the HPC. You can use Windows PowerShell or Linux/OXX command. And then if you do use PowerShell, I recommend downloading this PowerShell 7. It's an official open source version of PowerShell supported by Microsoft that's faster, has more features. It's different than the default one called Windows PowerShell, but just look up PowerShell 7.0 and you can download it. It's free, and like I said, we're still in Windows. And just as an example of what this looks like, it should be recording. Everyone should see. So if you go here, just a minute, yeah. So you go here and you type in SSH, then your username, and then the IP address. So that's the Quartz IP address. There's also a Big Red one that are on the official IU websites if you look that up. It's going to be the same for everyone. So everyone will basically type this command, except for you'll put your username instead of mine. So you type it in. It'll ask for your password. And then you have to put in your Duo codes. Also, make sure you have Duo Mobile installed. I mean, you should have it if you're a student and signing into anything, but you'd have to put in a Duo code. Let's see. 366. Yeah. So then after that, it'll sort of log you in, and then you'll be in Quartz. Then there's also a software called PuTTY. This is mostly for Windows. I know there's Linux and Mac versions, but I heard those are a bit iffy. But on Windows, it's very nice. It's pretty much the same thing as doing this SSH command, but you can sort of save your IP addresses. You can also save discrete settings. So you would just sort of go, you would type in your IP address, you would then type in the names, you would type in Quartz or Big Red, then hit save. But it means that every time subsequently, you just click on the Quartz button, you click open, and it'll automatically pull it up for you. This is pretty useful for using both Quartz and Big Red, as you can just have them both saved. You don't have to worry about scrolling through your command history. Then there's also a program called WinSCP. This is a free SCP client for Windows. It sort of just creates a visual where you can sort of have your file system and the HPC file system visualized on both sides. You can drag and drop between both. It's the same thing as using the SCP command, but it just kind of makes it a little bit easier to visualize. And I honestly personally use it just to visualize my virtual machine environment. So then we're going to go to our first example, which is understanding the file structure. If you haven't worked with a file structure before, so it can be difficult if you can't see it. So first you want to do is ls command, and this will just show you everything you have in your current folder. So this is all the stuff I have. It's a bunch of work stuff, and you can see there's some files, there's some folders. And then actually a good thing to do, I think, would be to put this down. And then, sorry, I'm not much of a Mac user. Oh, well, I'll just leave this up small. Yeah, I try to do split screen, but I don't know how you do that on Mac. Normally Windows, you just like drag.
Yeah.
Just hover over the feed.
Oh, to the right screen. And then, yeah, we'll do this. This will be a little small, but yeah, just get that big. And then sort of, if you're here, you can just make a directory. So make dir, this is how you make any directory or make a file. And we'll make one called demonstration. So then if we do ls again, you should see that. And now you have this demonstration. If you couldn't tell already, this is all in alphabetical order when you do ls. You can also do ls-l, and this will sort of give you more information if you do need this. You can see, it's kind of a complicated read-write stuff. You'll cover that later, but you can see the last open date or the last alter date, and you can also see the file size. But next we want to cover moving between folders. So the way you move between folders is rather than clicking on them, you do cd, which is change directory. And a little cool thing here is something called, we'll cover this a bit later, is tab completion, where you can sort of kind of automatically complete file names. So instead of typing demonstration, you can just sort of press tab once you reach a certain point and it'll auto-complete it. So now you're in the demonstration tab, and you can kind of see this right here where next to your name, you'll have whatever files you're in. So let's just make some more directories. We'll just do random, and then make directory. I just like random ones. Really just want to get deep within a subfolder structure. So now we're all the way in 1, 2, 3, 4 folders deep. And this can be kind of confusing, especially if you're on the HPC. Some of these file structures, they can get complicated. If you're ever lost, you can do this pwd command, and this will always print your full working directory, including your sort of home. Then if you ever want to get back to your home, which is your main one, you can do this squiggly. So you do cd, and then this sort of squiggly, it's usually the top left of the keyboard. It's sort of Siri activated. But this sort of squiggly equals your home. So my home is NUTR stands, but yours will be different depending on your username, but everyone's will always be the squiggly. So if you do that, it'll take you all the way back home. So we can go back into, and then when it comes to the CD, you can also go into multiple files. If I want to go into random, hi, bye, so you can type in that whole file path and it'll take me in there. And then you can also sort of go back only one file by just doing ... So if you do cd ... you'll go back up one. You can also combine multiple ... with a dash like this. So this will move us up 2. And if you go back 2, you'll go back at a demonstration. So now we can kind of control how much you're going in and out just to make things a little faster. And then the final thing with files is that if you ever want to remove them, you use the rm command, which is the delete command on Linux. You can do it on any file, just rm, then your file name, and it'll delete it. Granted, this is permanent. It is not like Windows. There's no trash can where you can go return it, and there's no warning. So make sure that you are very serious about rm. Make sure that you're looking at the file, or else you lose a ton of data. But to remove folders, you have to do this -r command. So if you add -r, that stands for recursive. It'll delete the folder and everything within it. So if we can go to rm, our demonstration, and then everything should be gone. If we go back to our ls, there's no more demonstration, random, hi, bye, all those, they are gone. The next we're going to cover is tab completion. If you have the data folder, the zip file called demo, which is in, I don't know if people have that or not, but there's going to be a folder in there called Academic Workshop 3. Make sure you have that on the HPC, because there's going to be, if you look in here, there's different events. So first we want to go to cd tab to go over tab completion. So like I said, this lets you complete file and folder names with the tab. So if you're typing in, we can look at our ls and we can see we have different files: badger, bear, cat, dog, rabbit. Another fun command is called cat, which stands for concatenate. It'll combine any two files. So we can do cat dog1, and it'll combine the output of those. But you can also use it on just one file just to get it printed to the screen. This is useful if you have a pretty small file because it won't take up a lot of space on your screen. You can just see what's in it. So with tab completion, we're going to do cat, and then we are going to do, you can see that if we have do C, it automatically goes to cat because there's no other files that start with C. If we do T, it goes to tabby cat because there's no other files that start with T. And if we do with R, it's going to go straight to rabbit because we only have files that start with R. But let's say we want to cover dog. So we do cat, we do our D. So it auto completes to dog because we have 3 files, all which have dog in it. So it's going to go up to your most complete. We see you have a dog1, dog2, dog3. It doesn't know which one you want, so it's not going to complete that for you. If you push tab again, it'll show you all the files that have that name. So you can see we have these 3, and then you can push your 1, and it's going to do that. And then if we do 2, and then we can do 3, right? But then it's also only going to complete up to the point in which it knows. So we see we have 2 files that start with bears. If we do cat B, it's not going to complete it. But the second we give a unique character, so that A, I'm going to go to badger. I don't know what badgers make. Or if you do B, it'll go straight to bear. So in general, when it comes to file names, it'll only complete up to the point where it's unique or where it knows what you're talking about. And like I said, you can always push that double tab and it'll show you exactly everything. So tab completion can be very useful if you have very long file names, very complicated file names. I recommend using it honestly for every file because it's going to prevent misspellings in the long run. With tab completion, there's no way you can misspell whatever file or folder you're going to. So definitely get in the habit of just sort of pushing tab to complete files. Yeah. So we'll go here and we'll do Nano. So Nano is a text editor. It should be installed by default no matter what on these HPCs. It's sort of the default text editor. And then where it works is you just type Nano, then you type whatever file name you want. So we can, if we go back to the tab, we can go Nano cat, right? And it'll show us the cat file. So you can see that there's the data there. We can add to it. There's different commands you can use. So if you do command, or is it control? Yeah, control or E. So you can see these all at the bottom. All these different commands. If you do control E, it'll move to the end of the line. Control A to the start. This can be useful if you want to easily add. You want to add another meow. Then to save files, you do control O, which will write, and it'll ask what name you want to write it to. If you keep the name the same, it'll overwrite the file. But if we want to write this to a different file, we can do cat2, save under a different name. So now we're editing cat2. So you can sort of create new files within a file using Nano. And there's also different, you can do, we type gibberish and do control K, it'll cut the line. And then we can sort of, the way you copy paste too is a bit weird. You actually use, actually on Windows, you use the mouse. I think here you can just do control C, yeah, command C. On Windows, you have to do a left click, right click. But yeah, there's also a sort of control W where you can find any line. So you can do find meow, and it'll find it. You can do command C and it'll show you what line you're on and what character you're on. This can be useful if you're coding and it says there's an error on line 500. You can kind of get a visual where that is. Yeah. You can also do control L here to go to any line. So you can go to line 3 like that. Those are the major commands. And then if you exit a file without saving, you can choose to either save yes or no. This can be useful if you accidentally make a mistake. You can just close out of the file and choose not to save, and then it won't overwrite it. So you want to do that. You can also create new files in Nano just by typing a new file name. So if we do bird.txt, it's going to create a new blank file called bird, and then we can add whatever we want. And we have bird. If you want to create an empty file for whatever reason, like maybe you just need a certain file, but you don't need any content in it, you can use touch, which will create a file, but it'll be totally empty. You can also use the sort of touch any other file. So it'll just, all that will do is just change the last modified date. It won't do anything. But let's say you had a file that you last edited a week ago and you do touch on it, it'll say it was last accessed today, but nothing happened to it. That's very niche effectiveness, but it comes up sometimes in programming where you need files to be more up to date. So sed is a sort of powerful text editing program. It's again by default. So if we do /h, we can see all the sed options. It's almost kind of like its own programming language. It can do a lot of complex things, but the most common thing people use it for is replacement. So we can go into any file and it can find and replace. So if we go to cd fastq, you can see you have a fastq file in here. And there's another kind of useful command. If you want to see if you have a very large file, like usually fastqs can get pretty large, up to a gigabyte. This is very unwieldy to edit in any text editor. And it can also, you don't want to use cat on it because it'll spit so much text to the screen that it will drown out all of your previous. You can use a command called head. So you do head and then /n. This tells you how many lines you want. So we want to 10 lines of this. And we can go to our fastq. You can see it's a fastq, right? We have our header with an @ our sequence, our plus, and then our quality data. SRA fastqs look very weird. I don't know what's up with them, but this is generally what a fastq is. And let's say you want to turn that to a FASTA because you want to use BLAST. But the difference between a fastq and a FASTA is that this @ is replaced with a greater than symbol, and you don't have any of this. So you could go and use an online tool to turn fastq to FASTA, but that'll take quite a bit. Or you could manually edit it, which will take even longer. Or you could use sort of a combination of commands. So we actually want to use one called grep, and grep will just find really anything in a file and spit it out. So we want to find, in particular, these first two lines. We want to find this header and this data. So you want to find the sort of unique aspects of that. Really, the most unique thing is going to be that SRR. Then we want to do /a. This will tell it to get one line after because we want this line after. No group separator. This is a very important command because it'll actually I'll show what happens if you don't use it. That would be more useful. So look, we found all of these, but we have this very annoying separator. If you try to put this into FASTA, or I mean BLAST or any other program, it's going to go beep beep. This is wrong. So you want to do this. So when you do this, you want to go do no group separator. I believe that's how you spell it. Okay, that is, I always spell this wrong. Yeah, this is also another useful thing. You can type help and it'll always tell you no group, all the different, you see there's a ton of different flags you can give this command. So it's sep. A second, oh. Yeah, so that'll spit out this. And then we can use sort of a pipe. And a pipe is this line right here. And that'll tell it to feed the data into our next command. So we want to do sed /s. So what this /s is saying is we're going to replace, then an A, that's going to tell it to find the @, and then it's going to tell it to replace it with the greater than, and the G means it's going to not replace it in the original file. In this case, it doesn't matter because it's actually reading it from grep and not the original file. But if we run that, we can see that, okay, we have our thing, but how do we get this into a file? Because now we just have it on the screen, and it's not really feasible to copy and paste this. So then what you want to do is you want to use this greater than symbol, and then we can type our name, and we can do that. So that's telling it to make a new file and to take everything it's printing to the screen and instead spit it out into the file. The single greater than will make a file, and it will replace everything in it. So if we do this, and go through, we can do our ls. We can now have a fastness. We do head / n 10. And then, wow, see, now it's a FASTA file. If we were to go and do, let's just pretend that we removed the set here, but we kept this the same. With this single greater than, what it's going to do is it's going to totally overwrite whatever file. So if a file doesn't exist, it will create it. If it does exist, it'll overwrite it. Do that. And we go back to our head command. Now you can see it's overwritten it, and without our set command, it still has that @ marker. Whereas if we sort of redid this, and you can see this is like a very fast command too. And it's one line. It's a lot faster than uploading this to Galaxy and using the FASTQ to FASTA converter. But if we sort of went down here and did our non-set version with double, so if we did 2 greater than, what it's going to do is it's going to instead, if there's no file, it's going to create a file. But if there is a file, it's going to append it to the end. So if we did this and we did our head command, we'll see that, okay, so it's the same. But if we did what's another command called tail, which is just the same thing, but it reads from the back, you can see it added the non-set version. Sed. I was talking about bash, so what is this? So bash is a scripting language, which is what this whole shell is based off of. You can make programs with it. They have the .sh extension, but you can also run it directly from the command line. This makes it pretty useful for automating a lot of tasks on a minor scale. So if we look at this, we have a bunch of files that each sort of go one after the other, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you put all of these together, you'll get a poem. So if you look at 1, 2, 3, there's a few different ways we could do this if we wanted to combine. These all contain a little bit of a poem, so they contain 1 word of it. Combine all of it, you get a full line. You could either, like I said, open these and manually copy paste them. You could do a cat command, like I showed earlier, but that would require typing out like 6 files. There's a way you could automate this, which is using the sort of bash scripting language. So if you look at this command over here, we have a for loop, so it's saying for f between 3 and 9, so that's the range. What it's going to do is it's going to cat, then this is a sort of text replacement. So it's going to say we're going to have 1, 2, and whatever f is, it's going to put f in there. So when f is 3, it'll be 123.txt, 4, 1, 2, 4. So if you can kind of tell, we have 3, we have 9. It's going to sort of write the contents of every one of these into this poem, and since we have double greater than, it's going to append it to it. So if we sort of copy paste this, or I can just type it out. In 3. Like I said, bash is a whole programming language all on its own. So there's a lot more complicated things you can do in it. It's very useful. But this is just, in my opinion, one of the most common things I use it for is automating pipelines. So let's say, you have a bunch of SRA reads, right? Those usually normally kind of follow. They iterate one by one and when they're uploaded in a set. So if you want to run a pipeline on, let's say, like 10 SRA data sets, and they all sort of iterate by one, you can do this for loop, and then it'll do it automatically for you, without you constantly having to babysit it and redo it. Actually, I messed that up. So we do, and then we gotta do done. So it's done it. We have our poem, so it's automatically, you can see how fast that was too, a lot faster than any single person. So right said Fred, let's do it again. That's a very old, like British nursery rhyme. You could also type this in a file if you wanted. So if we did nano test.sh, you could do for f in 3 to 9 do cat 1, 2 Then you just type bash, and then you would do this. So you can see it wrote the same poem again. So you can do this in the command line or in a file. So you can, normally we call these one-liners because they're just one line and they can accomplish a lot. If you saw the difference between doing command line and doing it in a program, in the command line, you have to represent every new line character as a semicolon. Whereas here, right, we don't have a semicolon. We instead use a new line to signal where the next part of every thing is. Bash is a lot you can do with it. Actually, going to talk about is the module system. So these sorts of HPC, it runs off of a module system. So there's a lot of different programs students may or may not need, and rather than either having them all installed or letting people have free reign and install whatever they want, the university has set it up to where all these things are modules you can load and unload. The first, like let's say we wanted to do Python. So we want to use Python. So let's check what version of Python we have. By default, we have Python 3.6.8. This is very outdated. There's a lot of programs that will not run on this. And normally you'd have to install a newer version of Python. But like I said, they don't want students installing whatever they want because that would just be chaos. If people could just wreck the supercomputer by installing all sorts of viruses or crazy programs. So instead, we do sort of module avail. And this will show us every module that's available. And you can see there's just a ton of modules, like so many. And you're like wondering, how do I figure out, which one of these is worth it? So what you can do is you can do module avail. You can type in the name of what you want. So you can also tab complete this. So you can do module avail Python. And it's going to find every module which has Python in the name. As you can see, there's multiple versions. There's like GPU Python. So this is if you want to use, you have stuff like TensorFlow and PyTorch pre-installed. So if you ever want to, play around with machine learning, these environments should be set up. They've been having some issues lately. I've contacted IT, but we want Python. Let's get Python 3.11.4. So you would do module load. So then it's going to load by default. And then if we do our Python 3/version, you can see we have Python 3.10.5. If you want to either downgrade and go to 3.9 or upgrade and go to 3.11, you have to specify which one you want. So we'll do 3.11, and that'll give us reload the module. So now, like I said, we do Python 3/version. It's going to give us 3.11. Like I said, there's so many modules. Maybe you want to use R. You go do. Oh, got to add module load. So we have 4.1, 4.2, 4.3. Let's do 4.3. And let's say you want a mini conda. You can do. I keep forgetting the load. You have mini conda, and then So there's so many different modules you can get, but you can always type module list, and it'll show you what modules you currently have. Some of these are sort of by default, like this new module by default. New is the name of the sort of system we're using, so you never want to unload new. But then let's say you want to save these modules. Like I know I'm always going to be using Python. I'm always going to be using R. I'm always going to be using Anaconda. You can type module save, and it'll save your current collection of modules. So every time you load up into Quartz, you can do this on Big Red too. So they both have separate modules, so you have to do this independently. But once you get your sort of normal everyday daily drivers, you can do this module save. So the next time you log into Quartz, all of these will be preloaded. You don't have to do any loading or unloading. And it's so if there's ever, like I said, a program where like maybe I need this, do we have it? Always do that module avail and then search the name of the program, see if the HPC already has it, and then you can just load it in. You don't do any installation yourself. There we go. Next, we're going to talk about Slurm. So the way that this sort of, so you have the supercomputer, you have tons of students, researchers using this. Well, how do you manage the resources of the supercomputer? Well, you use a system called Slurm. So if you want to use a job that takes more than 20 minutes or uses a certain amount of memory, I think it's like 20 gigs, or you want to use any GPUs, you have to submit a job. And this will sort of put you in a queue until the computer has the resources, and then it'll let you run your job. So just as an example, we have this sort of test.py. So we have our Python 3. And this just sort of prints out every number 1 to 1,000. So that was pretty fast. It doesn't take a lot of time, doesn't use a lot of memory, so we don't need to do a job for it. But if we do this sort of a test2 program, which does the same thing, but then it also does a bunch of complex math every time before it prints a letter. Oh, we don't have NumPy installed. I'm pretty sure NumPy is in the Python GPU package. Module load. Okay, I'll just do it. Yeah, so if you run this, we're gonna run this. There's a memory error because we're making an array that's so big in NumPy, it's going to go and break the array. And then let's do. So you can't really do that. So I'll just go and remove this line too. So to get around this, we want to set up a job. So the basic sort of job looks like this. We can sort of see we have our P, which is going to be our portion. You use general if you want to use CPUs, and then you do GPU if you want to use GPUs. This -A is your research allocation. To use Slurm, you need to have a research allocation given to you by a professor. This is very annoying. It used to be open, so anyone could use it via a general allocation. They removed that. So if you really want to do this and you're working, if you either have a lab mentor, they should give you one because you need this to do a lot of your research. Or if you're ever in a class, you can always just ask your professor, hey, can you please set up a Slurm allocation for us? And you'll get a certain number. And then you can do either GPUs per node. This is if you want to go use GPUs. You have your time. So another cool trick you can do is if you do Control R, it'll do a reverse search. So it'll look through all of your previous commands. So let's say I want to go do srun. I can type srun, and I can go look through all my past srun commands. And then you can sort of just use whatever one you want. The only annoying thing is if you don't find what you're looking for, you have to go all the way back to the present day. But it's pretty useful because you're going to be using these sruns a lot, and you're probably just going to want to reuse them. You can also set it up to be an interactive or a queued job. So an interactive job, you do it on the command line, and it'll run as long as your computer is up. But if a job is going to take a while, maybe you can't have your computer open. You can set jobs for 48 hours. You're not going to have your computer probably open with the PowerShell open for 48 hours. And even there's a big risk, if there's even a single little Wi-Fi hitch, like the Wi-Fi goes out for just 1 second, it'll disconnect you, your job is done. So you can do a queue job where you sort of type all of this stuff. Instead of you do it on the line, you do it in a file. So over here is just sort of a sample, a file. All of these will have this bin bash. Then you do sbatch -j for your job name, your partition. That -o will be the file where all the output is. That -e is going to be where all the errors are. You can then set to your email. So it'll email you when the job is queued, when it starts, when it's done. You can choose, this is for CPU. You do how many CPU nodes you want and how many tasks per node, your time, your memory, and then your allocation. Then you sort of load any modules you need. This is also where you can activate Conda environments. Then you type srun and you run whatever programs you need. All right, I'll do it. Bash. Let's see, hopefully we can actually get this to run. But a kind of cool thing you can do is you can srun, and instead of putting any program at the end with that pty, you put bash. Let's see if it'll actually work or not, but it should put you in sort of an environment to where for that like hour, set it for a time equal that, for that hour, I get full access to allocation. So I can run as many programs as I want, and it'll automatically use the allocation. It'll automatically use a GPU. So maybe if you're going to be running like a lot of programs, you maybe want to use that. The only thing with a Slurm is you do have to wait for resources. Quartz is usually a little less busy than Big Red because Big Red has the better GPUs, but still it can sometimes take a little bit. Yeah. Then another useful thing is you can always check and cancel jobs. If you type in SQ, yeah, I don't think this is going to happen. So if we want to go and do a job, so I'll go out here and just submit one of mine. Better script just to submit. So SBatch. So this will be, say it submitted a job. If we do SQ, you can see whatever jobs have been submitted. So what you really want to do is you want to do SQ/username, then your username, and it'll show whatever jobs that you have queued. You can also do scancel to cancel any jobs you want. I don't know why it's not showing up here as I submitted it, but normally you'd have your job ID, the name, the time, with the I guess it like already ran, and that's why it didn't show up. But you could always cancel it. So if you do scancel, you'll have your job ID listed there. You can either do -J, cancel it via the job ID if you just want to cancel one, or you can do -N to cancel it via name, or you can do /U and cancel it via your username if you want to cancel every job you have, or you only have one available. And there's sort of a conda and pip. So if you ever want to create a virtual environment, you want to use certain Python packages, or there's a package that program that is not a package on the HPC, or you need a specific version that the HPC doesn't have, you can set up a conda environment. You just do conda create /name, do workshop. So this is telling us we want a Python 3.11 environment. We can also, from here, you can add any packages you want to. So if let's say you wanted to install NumPy with it, we could do that. We could install pandas, right? So this is going to create an environment that's based on Python 3.11 that'll have NumPy and pandas pre-installed. And these sort of environments are discrete. When you go into them, every package, program, whatever will be installed locally just to that environment. The second you leave that environment, you can no longer use it. When you delete that environment, all of those are gone. It's a very useful way to sort of, if you're working on multiple projects, to sort of partition them out, because different programs and packages can have conflicts, and it's a good way to resolve that. It also makes it very easy to clean up at the end too, because you can just do a simple remove command. So it'll create it. And normally what I would do in this scenario is I would also put a -y flag. So where, maybe after you do -name, put -y. This would sort of automatically say yes to everything, because once eventually it's going to come up here and say, it's going to go through, it's going to ask yes or no if I want to install everything. I just didn't use it today just so I could show everyone what it looks like if you just do it by default. But if you don't want to have to babysit this, you can put -y and it'll automatically install. There may be sometimes you don't want to do it because conda can get a bit funky. The way conda works versus pip, which is also mentioned here, pip is another package installer. It doesn't allow you to create virtual environments, but it also allows you to install Python packages. Conda will install all of the necessary preconditions for it, which can be very useful. So you don't have to constantly be installing stuff. Pip won't do that. Granted, conda pip can get very complicated. There's sometimes where programs will be up to date on pip, but not on conda, or sometimes the version on vice versa. It's very confusing. You can also use conda to install programs too. So you can use it to install, for instance, SAM tools, just a lot of other things. So you can install programs, you can install Python packages. You can even install like R if you wanted to have a discrete R environment. You can install though, it's going to verify the transaction. Yeah, sometimes conda can take a while, which is the benefit of pip, I would say in the end, is that it's a lot faster than conda. But you'll have to kind of mix and match depending on your situation. It can be a very big pain to try and figure out what exact combination of conda and pip installs you need to do to get things like TensorFlow working. Yeah, so now to get into our environment, we do conda activate academic workshop. You can have multiple conda environments at the same time too. So now we're in our academic workshop environment. We can do conda install matplotlib, and then should install matplotlib for us. And I'm not gonna bother. It's gonna take a while to install, so we'll just not install it. You could also do pip too. You can do pip3 install Seaborn, right? And then pip will install Seaborn for us too within this environment. And pip will install it within your environment files, which is nice. Yeah, so it's gonna requirements already satisfied. I think I already installed pip, but so now we want to get out of it. We do conda deactivate, leave conda, and let's say I'm done with the project. I spelled it wrong. D. I misspelled. Oh, I misspelled the C and the A. We can do conda remove /name academic. You can't actually use tab complete on conda environments, which is why I'm not doing it. But yeah, you do conda remove /all. Yes, it's going to delete it all. Conda does leave a lot of junk behind. Even after you do this command, there'll be like gigabytes of junk, especially if you have a very large environment with a lot of big packages, stuff like TensorFlow, stuff like PyTorch. And the more you have, the more junk you're going to accumulate. So if you ever notice that it's saying your quota is up and you haven't done a full clean of conda, it's probably why. And I'll show you how to do a clean of conda once this is done. So you not only need to delete this environment with conda, you also got to clean up the trash it leaves behind. So you would do with once this is done executing, you do conda clean --all. Okay. There's not really much else to cover here. If people are here and they're on Windows, there's a lot of things that are done on Windows you can redo on Yeah, so it's just gonna say I'm gonna clean. But so for grep, you can do the select string, and path will be the file you want to search through. Pattern is what you want to look for. This context will tell you we want to get 0 lines before, 1 line after. This is the same as our grep -A1 command we use to get the first 2 lines of every for the FASTA. And then, like I said, the greater than symbols works the exact same on Windows as it does on Linux. This is a Mac, so I can't show this. A good, cool trick too is if you're in your file environment, so you're in your file manager, you right click, there's an option that will say open in terminal on Windows 10 and 11. And that will open up your terminal with the path pre-changed to where you are. You don't have to do any CD. And CD is the same on Linux and Microsoft. You can do this cat. So cat works the exact same. You have your file, you just put a comma between it, and you can do the same cat. You can also do one file to read it. This is the same as head and tail. So get content, either do dash head or dash tail. And then you want to do sed, you have to do a program called fart. Kind of a goofy name, but it's a program you have to download from GitHub. There's the link. What you do is you download it. It'll be in a zip file with the exe. You add it to your environment path. Then you can do your fart. Then you do your file name. You do what you want to find in quotation marks, and then what you want to replace it with. And this works the exact same as sed. I will say this select string, kind of weird. It automatically adds metadata to every line. So if you did this, let's say we did this on our, you could also use pipes too on Windows. So we did our same select string plus fart to do our fastq to FASTA. You would have the file name at the start of every line. I don't know how to get rid of that. Like I said, Windows command line, there you can do some Linux-like stuff with this, but it is very annoying to deal with. And that's part of the reason people pay big bucks to go to Mac, is because all of these commands are by default on Mac. So all these Linux commands we've covered, they're all on Mac because Mac is a Linux-based system. It's just more locked down than other ones. Is there anyone here that is not aware? We'll have a future event, a summer social coming. It'll be next Monday.
The Monday.
Okay, so it'll be the Monday after. It'll be in the atrium, a lot of fun. And there's a link tree. I'll make this full screen so everyone can see. Yeah, so there's the link tree. You can scan it. It's also on the tables. And that'll be all.